Download this code from codegive.com, link in the description below. Connection pool overload problems. Connection pooling is a common technique used in applications to manage database connections efficiently. However, if not managed correctly, it can lead to connection pool overloads. This typically occurs when too many requests are made to the database at once, exceeding the maximum number of connections allowed in the pool. This can result in performance degradation, increased wait times, and ultimately application failures. Common causes of connection pool overload. 1. High concurrency. When a large number of threads or processes attempt to access the database concurrently, they may exhaust the available connections in the pool. 2. Long-running queries. Queries that take a long time to execute can hold onto connections longer than necessary, leading to exhaustion of the pool. 3. Improper configuration. Setting the connection pool limits too high or too low can lead to inefficient use of resources. 4. Connection leaks. Failing to close database connections after use can lead to connections remaining open and not being returned to the pool. Solutions to connection pool overload. 1. Tune connection pool settings. Adjust the maximum number of connections, idle connections, and timeout settings based on the application's needs. 2. Optimize queries. Review and optimize any long-running queries to ensure they complete as quickly as possible. 3. Implement connection management. Ensure connections are properly closed in a finally block or use try with resources in Java. 4. Use asynchronous programming. If applicable, use asynchronous database access to free up connections while waiting for I/O. 5. Monitor connection pool usage. Regularly monitor the connection pool to identify patterns and adjust configuration accordingly. Code example: Java with Hikari CP connection pool. This example illustrates how to manage a connection pool using Hikari CP in a Java application. Hikari CP is a fast and reliable JDBC connection pool library. Step 1. Add dependencies. If you are using Maven, include the following dependency in your pom.xml. XML. Dependency. Group ID comsaxer/group ID. Artifact ID Hikari CP/artifact ID. Version 5.0.1/version, check for the latest version / dependency. Step 2. Configure Hikari CP. Set up the connection pool configuration. Java. Import comsaxer.hikari config. Import comsaxer.hikari data source. Import java.sql.connection. Import java.sql.sql exception. Public class database connection pool. Private static Hikari data source. Static. Hikari config equals new Hikari config. Config.set JDBC URL, JDBC mysql/localhost 3306/your database. Config.set username, your username. Config.set password, your password. Config.set maximum pool size, 10, / adjust based on your needs. Config.set connection timeout, 30,000, / 30 seconds. Config.set idle timeout, 600,000, / 10 minutes. Config.set max lifetime, 180,000, / 30 minutes. Data source equals new Hikari data source, config. Public static connection get connection, throws SQL exception. Return data source.get connection. Public static void close. If data source equals null. Data source.close. Step 3. Use the connection pool. When performing database operations, be sure to manage connections properly. Java. Import java.sql.connection. Import java.sql.prepared statement. Import java.sql.result set. Import java.sql.sql exception. Public class user DAO. Public void get user by ID, int user ID. String query equals select asterisk from users where ID equals. Try, connection equals database connection pool dot get connection. Prepared statement equals connection dot prepare statement, query. Prepared statement dot set int, 1, user ID. Try, result set equals prepared statement dot execute query. While, result set dot next. / process the result. System.out.println, user, plus result set dot get string, username. Catch, SQL exception e.print stack trace. Best practices. 1. Always use try with resources. This will automatically close connections, statements, and result sets, preventing connection leaks. 2. Monitor connection pool metrics. Use metrics provided by Hikari CP to monitor usage and performance. 3. Adjust configurations based on load. Conduct load testing to determine the optimal settings for your application. 4. Implement retry logic. In case of connection timeouts, implement retry logic in your application to gracefully handle transient errors. Conclusion. Connection pool overload can lead to significant performance issues, but with proper configuration, query optimization, and connection management, you can mitigate these problems. By following best practices and utilizing libraries like Hikari CP, you can ensure your application remains responsive and efficient.